Hello, good morning, students. Today you're going to learn about how to measure the change in the heat energy, enthalpy, and internal energy. Okay, we are going to use an instrument which is called as a calorimeter. A calorimeter, it is used for measuring the amount of heat change during a chemical reaction, and the temperature change is directly proportional to the heat capacity. So remember this equation: C is equal to Q by M into delta T. C is called as the heat capacity of the calorimeter. Q is the quantity of heat. M is the molar mass of the substance, and delta T will be the change in temperature. Now, the amount of heat change during a calorimetric process can be measured under two different conditions. That is, I can keep the volume as a constant, or I can keep the pressure as a constant. This is the instrument which is used to measure the temperature change or the heat change. It is called as a calorimeter, and it is also specifically referred to as a bomb calorimeter. Now, inside this apparatus, you have a sealed container in which a platinum vessel is being kept, and a weighed quantity of the sample is being taken. This yellow substance that you see is a weighed amount of the sample that is used for combustion. What is meaning of combustion? Combustion means heating. So I'm going to heat it. I'm not going to use the heat energy as such from the gas stove, but instead I'm going to use two electric wires which are being connected to a filament, and when the wires are being connected to the electricity, the filament glows and the heat energy is being produced, and due to the heat which is being produced due to the electrical energy, the sample is going to burn. And when it burns, it takes up the oxygen which is present there, and it gives out a large amount of heat energy. Before this reaction of combustion, the temperature of this whole system, which is being immersed in water, is being measured. That's the initial temperature. Now when it is burns, it gives out certain temperature, and that temperature is being dissipated by using a stirrer which goes to the water, and the temperature of water rises, and so the final temperature after combustion can also be measured. The sample under study here is benzoic acid, which is in a solid state. So the benzoic acid can be taken, and it can be used for the measurement of the delta U and delta H values. The total amount of heat that is produced in this reaction by using a benzoic acid in the bomb calorimeter it is equal to the sum of the heat which is absorbed by the calorimeter, the amount of the heat that is absorbed by the calorimeter, and the amount of heat that is being absorbed by the water. So two things I'm going to calculate. Now, how do I calculate the heat absorbed by the calorimeter? By using the formula Q1 is equal to K into delta T, where K is a constant that's called as a calorimetric constant. Okay, and it is equal to, this calorimetric constant is equal to mc into cc. Mc will be the mass of the calorimeter. I take the calorimeter, the mass of the calorimeter, and the heat capacity of the calorimeter. Okay, now how do I measure the heat which is absorbed by the water which is present inside the calorimeter? That can be done by using the formula. The formula that you'll remember is Q is equal to mct. Okay, this is the general formula that you will always be using. In this case, it is the for the water, Q2 will be mw, which is the molar mass of the water, into cw. Cw will be the molar heat capacity of water, which is a constant. We have to remember what is a constant. 4184 kilojoules per Kelvin per mole. So finally we arrive at the value of delta U C of combustion, that is internal energy of combustion, to be equal to this value. And this calorimeter constant can be determined by knowing known mass of the sample. Here it is benzoic acid. The heat of combustion of benzoic acid is this, also you'll have to remember, this is a constant, minus 3222.27 kilojoules per mole. Okay. And this is the final formula that you will have to remember for finding out the enthalpy of combustion. Okay, delta Hc is called as the enthalpy of combustion. Now the applications of a bomb calorimeter are given to you here. Now this is a small sample, okay, which you can perform even in your cups in your houses using a coffee cup. Okay, an ideal closed system is here. And then inside you have a sample, the reaction mixture, which can be stirred by using a stirrer, and the initial and final temperatures can be measured by using a thermometer. And this is a insulated stopper which does not allow heat to go inside or come outside. This is a nested insulated cup. So this is a small example of a calorimeter, okay, an arrangement of a calorimeter. In the physics lab, you will find a calorimeter which has been made up of copper, okay. So this is how using a calorimeter you can find out the amount of heat which is released in a combustion reaction.